I'm afraid I'd have to look that up. It's quite a while since I did my changes of state module. Anyway, let's move on. So we're going to kick off now with a presentation from Titan, and they've got two guys here. They've got Richard Lewis and Jean-Luc Casabian. Richard's going to start off, as I understand, and they're sort of doing a bit of a double act, and so they'll take us through what they're going to talk about, and then we'll switch over to Skymark on the video link. So over to you guys.
Perfect.
And,
thank you very much.
Let's sit back and listen. Thanks.
Thank you, Mike. So yeah, we've got a bit of a double act here today. Jean-Luc is a senior performance engineer, and I'm commercial director at Titan. But originally, I was an engineer. So let's kind of get that perspective. That I'm going to be talking as an engineer today rather than fully commercial. So for those of you that don't know Titan, I've just got this one slide up, just to give you an overview of who we are. Titan are a French company. I expect you've noticed my French accent. We've been in existence for 60 years. It's a family-owned company owned by the Pourpy family. We've got about 6,000 units in operation around the world, 80% export, and we've got 3 factories, 2 are in France and 1 is in Asia. And also, we've got a couple of support companies that are aligned to us. So it's quite a good group, been in existence for a very long time, and our core business is building aircraft refuelers, dispensers, refueling systems, and that's what we do for a living. So just one slide on who we are. So I want to take you through a story of how Titan got to where we are today in view of the electric range. And originally the challenge was, okay, how do we reduce emissions on airports? Now, these figures that we've got up here are kind of generally accepted by the industry. They might differ between airports, but essentially within the environment of the airport, within the perimeter of the airport, 60% of the emissions come from aircraft during takeoff and landing. The ground support equipment itself accounts for about 30% of emissions. And then we have APUs and the building emissions that come from various things like small diesel generators or whatever. So essentially, we've got a 30% opportunity to reduce emissions on airports with GSE equipment. As I'm sure you know, refuelers generally carry, well, a 20,000 litre refueler carries about 17,000 kilograms of fuel. So it's a big mass to accelerate and decelerate. So they're generally high fuel use diesel chassis, and they're quite polluting. So that's the opportunity we have within refueling, is to reduce emissions by about 17%. So that's the opportunity that we see. So Titan started our development 3 years ago with a bit of support from, encouragement from the French government. Really, the deadline was the Olympics in 2024. Let's show the world what we're doing, how we're taking our responsibilities seriously, and let's develop a range of electric refueling vehicles, electric hydrant dispensers, ready for the Olympics. So we did start 3 years ago. And what we have now is a range, and you can see on the left-hand side, you've got the hybrid range, which is electric refueling, but still using diesel engines. So we started off converting a standard diesel refueler to all-electric refueling. And then the knock-on from that was, well, let's take this kit now and actually retrofit existing vehicles in the fleet. So we're actually doing that already for some well-known companies. We're taking their standard diesel refuelers and converting them to electric pumping. And on the right-hand side there, you'll see our fully electric range. So it starts from a small trailer, a fully electric 20,000 litre refueler, hydrant dispensers, and the little yellow arrow is where we are right now, which is the SPR, which we'll come on to a bit later. But that's the life cycle, that's the journey we've been on so far. And we're just up to the yellow arrow. I'm going to hand you over to Jean-Luc, who I said was our senior performance engineer. He knows all about batteries.
Yes, thank you, Richard. So basically, as we handle jet fuel and avgas product, safety remains our main concern for our operators and end user. Our technical challenge was actually to work with major battery manufacturers to design a concept that will eliminate the risk of a thermal runaway in our battery pack. To do so, we combine the use of the BMS, the battery management system, which handle heating and cooling system of the battery cell, along with the addition of a dissipation layer, a dielectric layer, that came around each cell and insulated independently. You may be heard of the word thermal runaway, puncture test, or nail test, so I'm going to show you in the two next pictures what it looks like. Next slide, please, Richard. Okay, this is an illustrated comparison between the effect you may have on the thermal runaway. On the upper part, you can see that when you don't have any thermal dissipation layer around your cell, when a faulty cell occurs, this cell temperature can go up to 700 degrees Celsius. You will induce a propagation heat transfer to the surrounding cell that will lead you to the fire, the destruction of the whole pack, and obviously, you can imagine the severe consequences to the equipment that is installed on it. Our innovative design was to use this dissipation layer to cover each cell to contain the heat about each faulty cell that would be limited to 200 degrees Celsius. We will limit the heat transfer to the surrounding area to 50 degrees, which is the normal temperature working of the cell. Then we'll preserve the integrity of the whole battery pack, and in order to get the BMS to trigger an alarm and set the battery on a safe mode. As you can see the difference between the two pictures, the effect could be drastically different when we have that. And this is what we're looking at. Remain and ensure safety for our operation.
Thank you, Jean-Luc. So, I mean, these batteries are the ultimately safe batteries available on the market and actually used on some of the higher-end sports cars. So we're in a safety-critical environment. We couldn't use anything else, to be quite honest. So that's a good explanation of the batteries we're using. I just want to touch on the range that we have at the moment, and this is a message that we need to get out there. These aren't design concepts. These are products that are available. So I'm just going to briefly touch on all the products that we have at the moment. So I mentioned the EasyFlow, initially designed as an engine-off refueling system for our standard build units. So we have flow rates now from between 1,000 litres up to 2,000 litres a minute. A single battery can pump 110,000 litres on one charge, which is, again, I think quite remarkable, and people find that quite hard to believe, but we're consistently doing it, and we have units in operation in France, and some being exported now that consistently give us that level of performance. You've got near silent operation during refueling, which is great for the operators, so you don't have refuelers with exhaust gases being emitted on them. The refueling process itself is very quiet, and these systems are already in their second year of operation. So that's EasyFlow, our hybrid system. And on the right-hand side, again, as I mentioned, the EasyFlow retrofit kit. So we've actually started retrofitting the battery-powered pumping solution onto some oil companies' existing refuelers now, which we think must be, probably the lowest cost entry point into emission reduction. So you're not buying a new vehicle, you're not buying an electric chassis at the cost that Bernard touched upon. You're taking your existing equipment and making it more greener, more environmentally friendly. So that's a pretty good system when it's available. We have some really good data, so that system can save something around 14 tons of carbon emission per year on that system. So we've got a short video here of one of those vehicles in action. I don't know if I click again and it plays. So the batteries are maintenance-free, the motors are maintenance-free. For the period of operation of refueling, the engine's off, so you're saving the engine wear, the emissions. So it's a very, very useful system. The next product that we're moving on to now are our fully electric range. So this is the ETR, which you can have from 3,000 litres up to 11,000 litres. So what you've got is a battery pack, a direct coupled motor, a tank, and that can be for refueling avgas at low flow rate with an over-wing nozzle, or higher flow rates up to 1,000 litres a minute with underwing nozzle. We've actually supplied, I think, 7 of those into Africa and 3 into France so far. So it's a very good solution for the smaller airports, maybe the flight training schools, that kind of thing. And again, you have the improvements for the operators for the environment when they're refueling. Going to move on now to ERR20. So this is our flagship. We say it's the world's first modern, fully electric refueler. Now, I know some people will say, well, we built one 20 years ago. Titan did as well, to be quite honest. But the technology has moved on so much now, and we mentioned it earlier, the change in technology is really in the chemistry and the physics. So we have these modern batteries, we have these highly efficient motors, we have enclosed motors that are cooled, so they optimize the temperature. So it's a fully zero-emission refueler. Again, we're building those in capacities from 5 to 20,000 litres, and we've now released a model that can flow up to 2,500 litres a minute. And again, with that battery pack, it will dispense over 100,000 litres on a single charge. If your duty is higher than that, we can give you a double battery pack. So you then go from 100 to 200,000 litres on a single charge of those battery packs. The chassis itself has got a range of about 70 kilometres. It drives silently, it refuels silently, and compared to a diesel-driven refueler of the same size, our calculations are telling us we should save around 180,000 kilograms of CO2 per year just on one refueler. So really great product. We've got one operating in France, and last week we had commitment from a customer in Ireland as well. So that's the ERR20. And just a quick video from Joel Bateau of Total, and he's going to give his view on operating the ERR20.
Pour nous, les avantages du véhicule avitailleur électrique, c'est évidemment les réductions d'émissions de CO2, mais aussi donc l'amélioration des conditions de travail pour nos opérateurs, avec une amélioration de l'ergonomie au niveau de la cabine, au niveau de la souplesse d'utilisation, au niveau du coût d'exploitation aussi du véhicule, au niveau des coûts carburant, et aussi au niveau des coûts de maintenance, puisque les périodicités de maintenance seront beaucoup plus espacées sur le véhicule électrique.
So you can see on the ERR20, we have a very high flow rate unit. Again, just to summarize, we can pump around 200,000 litres of fuel on a double battery pack on a single charge. We've got a very low entry cab for great visibility, great turning radius, and these are available to the market already. I'm going to touch now on our electric hydrant dispenser, which is the EHD. Again, it's available in 2 flow rates from 2,500 litres a minute to the high flow rate, 3,850 litres a minute. Where again, we've selected a low profile cab with a great turning circle, low entry, both for the cab and for the platform. There's various battery options that are available for extended duty, and I'm going to touch on that on the next slide. But this is a JIG compliant, EN compliant hydrant dispenser. The first one's actually being built now and will enter service before Christmas at a European airport. And it can be fully charged from 0 up to full capacity within 5 hours on a 7 kilowatt charger. I've got a picture of a charger coming in a moment, but people seem to think you're going to need a great big box that's going to take half of the depot, but they're actually small wall-mounted chargers nowadays. The batteries have an 8-year battery life, and that's consistent throughout our whole range. And again, that's due to the chemistry of modern battery technology. And again, it's an absolutely improved environment for the operators with fully silent operation, no exhaust gas is being emitted during refueling. Now, this is quite an interesting one. So what we're able to do now is, when we've been developing the electric range at Titan, we did actually have to upskill a little bit, and we've recruited some younger people from the automotive industry, and they're able to now analyze a customer's duty cycle on airport. This particular one is an airport in the UK. The customer will carry out 20 refueling operations per day on mixed fleet, low wing and long haul aircraft, and the vehicle will travel 60 kilometers per day. So we're able to take that data, and on the left-hand side, the first chart you can see was where we selected a 33 kilowatt hour battery. And you can see in the circle there, at the end of the full shift, which was from 4 a.m. to 11 a.m. at night, the battery would have just around about 5% charge remaining. So we're able to go to the larger battery, which is a 52 kilowatt hour battery, and that battery will now give them the full day of operations with still over 23% of the charge remaining at the end of that duty cycle. On the left-hand side at the bottom, you can see the charger. So please don't be afraid you need a charger the size of a London bus for this equipment. It's a 7 kilowatt charger. And we've done the same also for the Iata 20, which is a fully electric refueler. If you can give us your duty cycles, we can come back to you with charging rates, duration of charge for the refueler, and give you some real-time data back of the battery we think you should use to optimize your duty on site. So at this airport, we anticipated we would save 180,000 kilograms of CO2 in a year for one refueler, which is, it's just quite remarkable. And I can hand you back now to Jean-Luc to talk about the SPR.
Yeah, so SPR, what is SPR? SPR stands for self-propelled refueler. Basically, what we decide to do in the company is, in the past and up to today, we buy road legal chassis which are designed, equipped, and certified to drive 600 kilometers per day at 90 kilometers per hour. We buy them, we deeply modify them to reach the needs we have for refueling operation. Instead of doing this, we actually decide to start from a blank page and design our own fueling chassis that will match all our requirements to do so. It was also motivated by the fact that the long supply delay we get from chassis manufacturer, such as the price variation that occurs way too often, reinforced that desire to do something that was perfectly designed for up and down operation many times a day during the shift. We started, as I told you, from a blank page. We set ourselves in a refueler shoes and say, what do we need as the features and benefits from a chassis and a whole piece of equipment? We compile all our customer specification, the whole industry standards, and merge all those data into our own build-up specification for this piece of equipment. As you can see, the SPR is a pivot articulated refueler. It works with different tank capacity. We get a low entry cab with a large view side. We get next to it mast type high reach deck, lifting deck that allows you better placement under the wing. We have an innovative rationalization piping fueling module that allows us to offer low, mid-flow, and high-flow rate in the same design and in the same dimension. Whatever long haul or short haul you will do, you will keep the same dimension. As we were looking into the future, this equipment is fitted with all the proven technology you can find up today on the automotive industry. You will have, for example, no rear classic view mirror, but it will be camera. You will have a 360-degree bird view to help you under the wing with the problem of coactivity with luggage cart, water truck, whatever. We'll also have some active prevention collision system on the foreside of the truck, and many much more. As we look in the future, as Bernard was telling, today, in 2022, this truck will be released in an electrical version, and we didn't stop our roadmap of thinking about how we can improve our end user to contribute to the reducing of the CO2, but it's going to be a fuel cell version as well, working on hydrogen.
Thank you, Jean-Luc. So yeah, just in summary, I think we were fortunate at Titan to start our journey early on. I think we we anticipated the market. I think we all have an understanding that probably the next solution for GSE and aircraft refueling is going to be electric. Hydrogen is a little way off yet. So we did start our journey a few years ago. So we now have the hybrid technologies. We have a system that can put electric pumping onto standard diesel units. And we have a range of electric vehicles that are ready now for the industry. But, you know, I have been speaking to airports now as well as oil companies. You know, they're a new customer of ours, and, you know, they're suggesting to us that they want to move forward. My local airport in Bristol in the UK want to be carbon neutral by 2025. So I'm now telling them what products are available to the market, but they're not always coming through from the oil companies. So, you know, we just want to let the world know it's available, and it's working well. It is working well.
Excellent.
So I think that's it for me.
Yeah.
Thank you.
Thanks very much, guys. That's great. Thank you. All right. Okay, so that's one perspective.